guys, welcome to the last section of the practice problems where we're going to go over the last 2 pages, and I'm going to tell you a bunch of stuff about the test tomorrow so that you're super prepared. So we're going to be working on the last 2 pages, 7 and 8, and I've just got a couple more of these chain rule problems. Okay. I've got this really fun quotient rule problem here, okay? And I want to know about the graph at pi over 4. So, we've got low, d high. Now, d high is a chain rule. So we got the derivative of the inside, that's negative sign, over cosine, right? Because the derivative of natural log is 1 over what's ever in there. Okay, so we got low d high minus high natural log of cosine d low. And d low is secant squared x all over low. So tangent squared. So sine over cosine gives me tangent. So now I have negative tangent squared times 1 over cosine minus natural log of cosine over cosine squared all over tangent squared of x. Okay, and I want this at pi over 4. Now the cool thing about pi over 4 is its tangent is 1. So that's 1 times 1 over root 2 over 2 minus natural log of root 2 over 2 over root 2 over 2 squared all over 1. Okay, and if you don't know that, that's from your unit circle. So I have negative 1. Actually, I have negative, I'm going to flip that, 2 over root 2 minus natural log of root 2 over 2 times, and then I'm going to flip that, that's going to be 4 over 2, which is negative 2 over root 2 minus the natural log of root 2 over 2 times 2. All right, remember, I don't need an exact answer. I just need to know if it's increasing, positive, decreasing, negative. Vertical tangent, that would be undefined, so the bottom would be 0. Horizontal tangent would be 0. Okay? And then no conclusion. That's rarely the answer, let's be honest. Okay. So this one, I just need to know positive, negative, 0, or undefined. Okay, it can't be undefined. There's no way. Okay. Natural log, if you remember the graph of natural log, it is almost always positive. Okay. So this is going to be a negative number, and this is a negative number. So negative minus a negative is going to be negative. Therefore, it is decreasing. Okay, so on those, you're just looking, is it positive? It's increasing. If it's negative, it's decreasing, etc., etc. This problem was on the study guide. If you didn't get that, that's okay. We'll go over it one more time. So it's a chain rule. So you start with the derivative of the inside. That's 1 minus 3 e to the negative 3x. Okay, that right there is a chain rule. Times, and then natural log is 1 over whatever is already in there. Okay, so we get this guy over the original inner function, and we're going to plug in 0, which is where most people struggled on the study guide. So e to the 0 is just 1. 0, that goes away, so I have 4. And again, e to the 0 is 1. So that's negative 2 over 5. So A. All right, this is a real fun problem. This is like the mother of all chain rule problems. Because it's a chain rule, yes, but in here, that's a pretty gnarly quotient rule. So we've got low d high minus high d low over low, low. Okay, so that's just the derivative of the inside. Then on the outside, we're going to have to power rule that. So you just leave the inside alone. Raise to the 3 now, because you subtract 1, just like back in the day. Then we're going to go ahead and clean this up. Okay, so that's going to be 6x to the 7 minus 3x squared minus 10x to the 4 plus 20x. Unfortunately, none of those clean up too nicely. This should have been low, low, so there should be a squared there. Okay. Times 3, and these can be split up. That's part of your exponent rules. Then we can plug in 1 pretty much at any point. It might be nice to put these together, but we can plug in 1. So I got 6 minus 3 minus 10 plus 20 over 2 minus 1, that's 1 squared. We're going to get 1 here too. 3 times 1 minus 2 is negative 1 cubed, so it's going to be negative. So I've got 3 plus 10 times negative 3 all over 1. Okay, so that's 13 times negative 3, which is negative 39. Ooh, not there. Let's see, what did we do wrong? I didn't try this problem before. Okay, let me grab a spare sheet of paper. I know you're probably seeing my issue. You're like, Miss Ibsen. All right, I'm gonna start again from scratch. So y equals, and feel free to skip ahead to figure out what I did wrong, especially if you already know. So dy dx, we've got low, d high. All right, did I do that step right? Yes, I did. Minus high, d low. Ooh, I found it. I found my issue. On the very first step, I dropped the 4. And you guys probably caught that because you guys are way smart. Whoops. All right. Low d high, high d low, over low, low. This is what I get for doing these problems at late. Ooh, I made another issue. Okay. That should have been a 4. Ibsen. No math at this time of day. 4 x cubed. All right, and that's cubed. All right. Then we can go ahead and clean up. So that's 6x to the 7 minus 3x squared minus 10x to the 7. There we go. Things are happening. Plus 20x to the 4th. Cubed. Right. These combine, so negative 4x to the 7 plus 20x to the 4th. Hopefully I did it right this time. Cubed, so that becomes 5th. All right, now I can plug in 1. So I get negative 4 plus 20 minus 3 times 4 times, and then I think we got negative 1 cubed here, so negative 1 over, and that was 1. So now I have 13, no, negative 4. 13 times 4 over 2. Yes, 52. So it's E. So sorry about that, guys. All right, one last problem in the actual study guide. All right, the line of the equation is normal at that point 1, 4. Okay, so that's the equation of a normal line. The most important thing that you get when you get an equation of a line is slope. Okay, so I'm actually going to rewrite this in a way we recognize as slope. So y equals mx plus b. So subtract 7y equals negative x plus 29. Divide. So slope of the normal line is negative 1/7. Okay. So that means the slope of the tangent line, aka the derivative, has to be 7. So we want to know what that slope is. Oh, and we don't even have to solve. It gives us 7. There you go. All right. So something that didn't come up in any of these videos that's definitely on the test are derivatives of inverse functions. Okay. So if I want the derivative of an inverse, okay, that's an inverse, I want the derivative of it. We can do 1 over f prime of the inverse. Now that seems like a lot of work, but it's really not. Okay, so for instance, a problem like that might look like, let's say f of x equals x cubed minus 2x squared plus 4x plus 17. Okay. And this isn't the nicest problem. F of, let's see, one is, 1 minus 2, so f of 1 17, 18, 19, 20, 21, 22, subtract the 2, so 20, right? Negative 1 plus 4, that's 3, yeah, 20. All right, so f of 1 is 20. So if I wanted to know the derivative of the inverse at 20, okay, what you would do is you do 1 over f prime of f inverse. Okay, so f prime of f inverse of 20, well, we know that's 1 over f prime of the inverse of 20 is a 1. So basically all you have to do is take the derivative and plug in 1 and put it underneath. So the derivative of this function here, 3x squared minus 4x plus 4, plug it in at 1, I get 3 minus 4 plus 4, that's 3. So your answer would be a third. Okay. So those come up like this, as well as graphically and in the tables. Okay. The other thing we did not talk about in these practice problems, but will come up, are derivatives of inverse trig functions. So the derivative of inverse sine or arc sine, you will see them either way. I think you actually see them both ways. 1 over square root 1 minus x squared. Okay. So let's say I asked for the derivative of inverse sine of 3x. Okay. That is a chain rule problem. So you start with the derivative of the inside, which is just 3 times, and then use this here and make sure wherever you put the x, you have that. So you get 3 over square root 1 minus 9x squared. For cosine, it's the exact same thing, but with a negative in front of it. Okay? And that's the case for all the cofunctions. The derivative of tangent inverse, or arctangent, is 1 over 1 plus x squared. Okay. For cotangent, it just has a negative there. And then secant is the fun one. It's 1 over the absolute value of x times the square root of x squared minus 1. Okay. And again, x is actually whatever function's on the inside. This is the main way I can ask about it. I can also ask about it within another function. So I could ask for, I believe we've done this one, arcsine of x plus the square root of 1 minus x squared. And that's a really fun one because things start canceling. So the derivative, actually I even think I made like this a product rule problem here, but I won't for this time. So arcsine, just memorize these guys. Okay, so that's the derivative there. Plus, and then we've got chain rule, derivative of the inside, and then distribute your exponent and subtract 1. So I get 1 over square root 1 minus x squared. These cancel. So I have minus x over that. So I get 1 minus x over square root 1 minus x squared. And then you could rationalize, but no need at this point. Okay. All right. Now, the most important part of any of this, we're going to go through, and I'm going to tell you exactly what's on the test, problem by problem. Okay? No, you don't get to see the test. I'm just going to give you a general idea of what I'm testing you on. Okay, so there are 14 MCQs. Right, this is more than normal, but it's fun. So, number 1 is a chain of a trig function. Okay, so you need to know your trig functions. Derivative of sine, cosine. Derivative of cosine, negative sine. Derivative of tangent is secant squared. Okay, you need to know your other 3 functions as well. So secant is secant tangent. Cosecant is negative cosecant cotangent. And what's left? Cotangent. Okay, so you need to know all 6 of those. Number 2 is a chain with a normal slope. Okay, remember normal equals perpendicular. Okay, so you need to know when to switch it. Number 3, that is an inverse function with a graph. Okay. And remember, x and y switch. Number 5, it's a chain, okay, but I want you to solve for x, and I bolded that. Okay, instead of plugging in, I need you to figure out when it equals the derivative that I gave you. We got a quotient slash chain for this one. And we have 2 of those actually. And then we've got a straight up chain rule. Okay, lots of chain rules. That's the main idea of this entire chapter. Then we got implicit. Okay. I've got 2 of those. 10, I've got some inverse trig. Okay, arcsine, arccosine, etc., etc. And chain. 11, we've got just an inverse function derivative. Another inverse trig for number 12 with a chain rule in there. A higher order derivative, okay, where you take the derivative more than once. And then the last one is another chain rule problem. Perhaps implicit differentiation, perhaps inverse trig, a lot of stuff going on in number 14, okay? And then the free response is pretty much everything, okay? There's a bunch of mix in there. Okay. Just a reminder that if the derivative is positive, that means the original, not with it, is increasing. If the derivative is negative, the original is decreasing. If the original is equal to 0, okay, it's got a horizontal tangent, okay, that might be a maximum or a minimum. If it's undefined, so a number over 0, that means it's got a vertical tangent. It's straight up and down, and that's undefined. All right, so go home, study, do your best. Come see me if you have any problems. You guys got this. Make sure you like and subscribe for the next one. See you tomorrow. Bye.